I like this quote from the famous economist John Maynard Keynes. When my information changes, I alter my conclusions. What do you do, sir? Like, it's a good question. You know, what do we do? And I think it helps to reframe this in terms of our profession. So when my information changes, I alter my design. But do we do that? Is it as simple as that? And so one of the things I always tell designers is to have strong ideas loosely held. And strong ideas because basically weak ideas are uninspiring, right? That it's the essence of being a designer to have a strong opinion. It allows you to develop an argument about a point of view, allows you to push up against it, and allows other people to challenge and respond to you. But being open to change doesn't mean that you don't have a strong conviction to start with. But it's really the flexibility of our stance within those strong ideas that allows us to be human-centered. So how do we hold on to ideas loosely so that we can change them and evolve them? How can we be open-minded and adaptable? I think we want to be those things. We would agree with that. But how do we actually do it and not just have it be some sort of lofty goal? So I've been thinking about this a lot, and digging into it, it led me to really two fundamental questions that I think deserve more exploration. So one, where do strong ideas come from? What informs our design decisions in the first place? And then two, how do we hold them loosely? How can we remain open to their evolution? And in this talk, I'm going to go through those one by one. So tackle the first one. Where do strong ideas come from? For this question, I don't want to recap the whole design process. I'm not talking about you could say design ideas come from the design process. That's not what I'm talking about. I don't want to go over design thinking or talk about different process methodologies. I'm specifically interested in exploring this meaty, mysterious middle of any design process, ideation, which looks like less of a middle once everything gets faded out. But I'm talking about this moment when there's a couple of experienced designers sitting in a project space and working through a problem and making decisions, design decisions. This is my favorite moment. This moment of a project is really why I'm a designer. I love this. And what's actually happening in a moment like this? What's going on, right? We're not brainstorming necessarily. We're not analyzing data. We're not following some kind of prescribed steps of a method that someone has told us to do. What are we doing? Where are these ideas coming from? And lately, I've been drawn to the way that the writer Donald Schoen describes it. So he says, design is a conversation with the materials of a situation. And this, to me, is the best phrase I've found for describing how I think about design. Design is a conversation with the materials of the situation. So at this point in a project, we're immersed in the research. We're already familiar with the needs of the user. We know about the medium we're designing for. We know about the business goals we want to achieve. But we haven't yet turned that information into a design. And Schoen talks about this in his book, his excellent book, The Reflective Practitioner. And what he's talking about, what he's articulating, is a way to think about and demystify the iterative design process. And he calls it a conversation because each design move that we make influences another one. It pulls it along and constrains certain possibilities and opens up others. And he talks about how the overall situation talks back as we go through this process. And we see where the conversation of design takes us. And to have this be effective, it really requires you to have the ability to oscillate between macro and micro thinking. You make a small little change, you step back, you see how it affects the whole, and then you decide if you want to commit to that or make another change. But this shouldn't feel forced, right? This should feel something playful, something probing, and somewhat natural. There's no direct path that we're taking to an eventual outcome in this conversation. And I think this conversational metaphor really works. If you think back to just the best conversations you've had, or even just good conversations you've had, right? They unfold unexpectedly. They surprise you. You didn't go into them necessarily knowing where you were going to come out. And the person you're talking to, you appreciate them more at the end of it, and you see them as a deeper, more complicated person than when you started. And the same is really true of designing, right? We're designing for a certain situation, and the qualities of this situation reveal themselves through this process of working through them little by little. But how does a situation actually talk back? What does that mean? As designers, we're sketching new ideas. We're continually asking, like, what if? What if it's like this? What if it's like this? But how do we hear the answer of how it should be? Evaluating every move that we make, every design decision with the users is pretty impractical, right? Every single one. So in these situations, it's often said that designers are relying on their intuition. And that word is kind of a problem, or it's a problem for some people, right? That it denotes this unconscious and indescribable force, which makes some people uncomfortable, but it's also a problem because it's harder to collaborate with other people when we can't describe what we're doing and where ideas came from. So I think we need to dig deeper than this. I think we need to consciously reflect on where ideas come from. So instead of using shorthand, let's actually try to dig in to ask what informs intuition. And so looking again to Schoen and the work that he was doing, he talks about and admits that like designers often know more than we can say, right? There's some force that we can't necessarily describe. But I find his deeper analysis into that to be pretty insightful. He talks about how any professional practitioner, and he defines this broadly, encounters certain types of situations again and again. And we build up this experience in a way that we can recognize and describe deviations from the norm much more easily than we could sit down and describe what the norm itself is, right? We're built for this kind of pattern recognition. We can feel our way around these patterns and what feels normal. And I think this is super relatable. I think everyone in this room has probably worked through different design ideas where you keep at it until it feels right. And that indescribable feeling is basically drawing upon this aggregate norm of all of our past experiences. But that's still not fully satisfying. It's a little bit fuzzy, right? Because most of us are constantly designing new things. So each new situation has so many unique elements to it. It's not like a game of chess where we can like recognize the exact same layout of the board from a previous game and know what to do, These patterns are not precise that we might be recognizing. And that's why instead of memorization, I think we're actually utilizing generative metaphors. So we're drawing upon our capability to see as and do as. We're mapping inputs from one thing that we are familiar with to something else. These inputs and outputs, just mapping them from one situation to another in order to draw upon experiences even if they aren't exactly the same. So, for example, if you're designing a better emergency room, it might be fruitful to think about it as a raceway, pit stop or a restaurant kitchen, right? So these are all busy, high-efficiency environments. What similarities can inspire you to look at the emergency room differently and maybe relate to something that you can have a more direct experience with or learn about in a different way? And this notion that I'm talking about of seeing as and doing as that Schoen talks about, it can happen at that macro level of like the whole situation, the emergency room. But it can also happen at the level of a micro interaction. So if you're designing a home security system, for example, and you want to explore different ways that you could activate the alarm, what are the different ways that we could rethink this? What if you thought of it as a washing machine? What if you thought of it as a musical instrument? So these can actually kind of get silly sometimes, and they definitely don't always work, but spotting even like these oblique similarities between one thing that you're designing and something else allows a designer to draw upon her past experiences and inform a new design. And you could choose to do it as an exercise. It's like something you could do at a certain point in a project, but I think good designers are just doing this all the time, and that we're doing it unconsciously a lot of times. And that's because I think this act of seeing as and doing as is design intuition, which is why our ability to rely on intuition gets better over time, even when we're tackling completely new situations. But what about when our intuition steers us wrong? What about when we don't really listen very well in this conversation with the situation that we're having, and we go down a path that leads to less than ideal solutions? In short, how do we remain open to the evolution of our design decisions? So that's bringing us back to our second question. How can we hold on to a strong idea loosely? And we could go back to the design process, right? We could look to that for help. So we could prototype ideas, we could test them, we can iterate on them. And this is useful, right? This is something that I'm sure we all do. This is something we should be doing. But this does not solve the problem. Going through these motions doesn't guarantee that we're going to hold on to our ideas loosely and remain open to their evolution. So, basically being open to change and wanting to have that is easier said than done. And one of the problems is that our very nature is working against us. So when we test and we iterate on ideas, we have to overcome problems that are built into us, like confirmation bias. So this is the tendency, confirmation bias is the tendency to search for and interpret information in a way that confirms the outcome that you already want to achieve. So I think the most important thing to understand is that confirmation bias is not intentional. It's not something that you wanted to do. It's something that our minds slip into automatically. We're genetically predisposed to hold on to the beliefs that we already have, to seek out information that proves what we know is true. And so for this reason, we need explicit tactics to avoid this bias, this confirmation bias. And I think the best way that that's embodied is we need processes and tools for making sure that we hold our strong ideas loosely enough. So part of this is how we test our ideas. And when we're testing a design, do we show it to people and get them to give it a thumbs up or a thumbs down? And if you do that, you're slipping into, it's easy to slip into this trap of confirmation bias. And really what you're doing is you're trying to validate a design rather than evaluating it. And those words are very similar, but they mean very different things, right? Like you can validate an engineering problem. Validation is about checking the accuracy of something, but you can't really validate a design. And when you do, again, it falls into this trap of confirmation bias. So I want to look at an example of what I mean by that. This is an old friend of mine, the NPR News app. And let's say, this is for your mobile phone, for iOS, this one. Let's say that you've designed this app, and you have this idea that you want to give access to the latest news on a mobile device with maximum flexibility, okay? So you design this app, and when you open the app, you can scroll through all the latest stories, you can select the stories that you want to read, or you can choose to listen to them, it's your choice. You can add them to a playlist, you can put together different playlists, you can access the entire archive of all of the previous shows. So there's a lot of content in here, and the user is in complete control. So you design this, seems like a pretty good design, and you test it. You give it to people to use, and they like it. You know, they find it convenient to have everything right there on their phone. They are able to find the stories, they're able to read them, they can add it to a playlist. It's basically successful. So you've tried to validate this design, and actually the result feels pretty good. Like you've gotten some positive feedback, and the design was well received, and you're happy with it. But if you stop at this point, what you risk is falling into a particular type of confirmation bias that's called congruence bias. And this is when you test your hypothesis exclusively through direct testing. You're looking for that thumbs up or thumbs down when you put it in front of people. Does this particular idea work? A good way to overcome that is to also test the opposite approach. So this is a different app that NPR recently put out, makes for a good example. It's called NPR One. So with this app, it opens up and it just immediately starts playing the latest news. It has limited selection capability. You can't read any of the stories. You can't rearrange the playlist or access the archives. So let's say that your original hypothesis, your strong idea, was the previous design. You think that users want more flexibility and control. If that's true, then feedback on this design should be a mirror image of what you heard on the other design, right? You're actually still testing the previous idea, but now you're doing it indirectly. By showing people something that would be appealing if your original hypothesis was wrong, if it was incorrect. By going to extremes like this, by testing an idea that we believe in, but also its opposite, we can avoid our tendency that's built into us for confirmation bias. And instead of trying to validate a single design, we evaluate the reactions between these two, and you know what? It usually isn't one or the other. There's usually a point in the middle, and we can reflect on that feedback and find that point between those poles of where the right design should live. You can't just decide that you're going to hold on to an idea loosely. You can't just want that to happen. You have to put it in a situation that causes it to slip away. You need to hope that there's more to learn and stop rooting for your idea to win, basically. So testing ideas like this is one way to try to keep them loose. It's a process, a technique we could use. And it works well. It works well in the beginning of a design phase. But there's this other human tendency that gets in our way later on, and that's this idea of the sunk cost fallacy. So a sunk cost is time or money, something that we've invested that we can't get back. You know, it's spent. And rationally, that shouldn't affect our future decisions because it's spent either way. But that is not how humans work at all. You know, we are hardwired for loss aversion. And so we want to keep trying something even if it isn't right. And so again, awareness of this helps, but because it's actually built into us, we need processes and tools to overcome it. And one of the best ways to deal with this is just to reduce the investment up front, reduce the investment cost in the first place, so there isn't as much pain to fall into the sunk cost fallacy. And this is where low fidelity prototyping comes in. So reducing the investment of time, money, effort that you put into a prototype. naturally sort of loosens the connection that we have to it. And at IDEO, we utilize like a bunch of different low-fidelity prototyping techniques that I'm sure many of you use as well. And we try to keep these ideas flexible as late into the project as we can. So, just a couple examples. This was a very early sketch for a financial project with PNC where we were exploring different ways of visualizing investment financial data, right? We chose to stay on paper for as long as we could until we were confident in the overall like high-level direction that we were headed in. And we could just throw away ideas. We were just throwing away scores of ideas a day because the investment was so low. This is a physical space that we had mocked up when we were designing a pharmacy, the new pharmacy experience for Walgreens. It's foam core. That what looks like a shelf is actually just a giant plotter print on some foam core, because these simple tools allowed us to just try new things. Realistic materials and real walls and things were not worth it. We didn't need them to get at whether this was the right direction, and these materials helped us remain flexible. In both these examples, we just chose whatever was fast and cheap. We were just trying to learn if we were headed in the right direction. You can see that to the extreme here. This is a initial user research for a vehicle HMI that we were designing, the human-machine interaction inside of a car. And this is an incredibly low-resolution prototype. Like it's basically blank. It's just enough to have a conversation about driving and the basic location of where we might put screens and knobs, inputs and outputs. So these low-fidelity prototypes, they're very useful in testing initial value propositions, very early phase, macro-level ideas of what we might do in the design. We make sure we're headed down the right path. But increasingly, what we're finding in our work is that once we get a little bit further, the experiences we're designing get complex really quickly. And what we're creating is actually this kind of orchestration between a bunch of different interactions. So it's not just one screen. It's actually the design, and what works in the design is about how this works with that, works with this, and how they come together to create a whole experience, whether it's in a pharmacy or in a car. So there's many different pieces of hardware and software, and when we evaluate these experiences, our prototypes need to be more real. They're more interactive. They utilize real data. They have real-time sensors. We're prototyping them live with people in realistic situations. And we rely on a lot of tools to help make that easier, to try to keep ideas loose, like Raspberry Pi and Arduino and these things that allow you to do really quick hardware-software prototyping. But these really only help make that one component something you can prototype quickly and remain flexible with. Where things really start to become challenging is getting everything to talk together. So just a tangible example of that, at IDEO we learned this the hard way, basically, by building out a vehicle simulator. So that previous prototype of the vehicle that you saw, that evolved and eventually became a full-fledged vehicle simulator. And this was 2012. The goal of the project was to imagine a completely immersive new interface experience for a car. So we're dealing with hardware and software and voice input and output and lighting and heads-up displays and haptics. Everything was up for grabs, and that was exciting. And as usual, things started pretty simple, like you saw, but then they got complex really quickly. We started adding all kinds of different inputs and outputs and trying out different things. We had a lot of technology challenges. We were trying to knit together 6 different video displays, a bunch of LED lighting effects, a bunch of different motor-controlled mechanisms. The system started to get overly complex and really fragile. The various components of this simulator had to be booted up in a certain order to work, and if you made a small change, it just brought about this cascade of problems. It was a mess. And really, this was the opposite of holding on to ideas loosely. Once we got something to work, there was this huge disincentive for us to make any change at all. And in the end, we pulled it off, we got it done. Everyone was excited to scamper inside the car and see all of these things work together. And they were thrilled to see it in action. And it was exciting for us that we could even pull it off. But that kind of like heroic accomplishment, where you're like pulling all-nighters and like barely getting something to work if you boot it up right, like that is not where you want to be. That is the enemy of holding an idea loosely. You're really not open to change at that point. So as we got closer to the end of the project, once we got something that actually worked, we just stopped iterating. We were just trying to keep it working. And then our client asked us to do it again. And it was a different project, it was a different car, but it was the same level of complexity. And we knew that we needed some kind of new tool to make this better. Like it just felt wrong that we were working in such a fragile environment. So we took a look at it and we realized that for this type of prototyping, the core of the problem was really one of messaging. So like I said before, we could use these different components, but getting this diverse set of technologies to easily talk to one another was the major challenge, and where a lot of the fragile qualities were coming from. And so we wanted to eliminate that complexity that was bogging us down. And that's where this open source toolkit called Noam was created, that we created to solve this problem. And so it's an open source messaging platform. And this isn't messaging like between people, it's messaging between components of a single prototype that uses multiple elements. And so it allows you to create these complex interactive products and prototypes by easily networking hardware and software together. And we didn't want to have to build this. It wasn't, we had hoped to find something off the shelf that we could just utilize. And so we took a look at what was out there. We looked at protocols like OSC and RabbitMQ and tried platforms like Max and SpaceBrew and all this stuff that like we weren't really familiar with, but it's out there. And it kind of worked, but it wasn't quite right for like the way designers build prototypes. It wasn't removing that complexity that really allowed it to just be a seamless part of the design process. And so, it kind of removed one complexity and added another, if that makes sense. But ultimately, we realized that we needed to build something for ourselves. And so that something is called Noam. And you can think of it through a conversational metaphor. So there's different technologies, and they speak different dialects, right? So getting them into a single coordinated conversation is what the real challenge was. That's what we needed to overcome. And this is why we were so excited about the previous vehicle prototype working at all, because it's a pain in the ass. And so Noam is designed to sit in the middle and moderate this conversation and provide translation between these dialects and pass messages back and forth between these different components, the different participants in the conversation, if you will. So using Noam, the hardest part of this multi-element prototype actually becomes simple and flexible and lets us hold onto our ideas more loosely. And the great thing is, lets us make design changes up until the last minute, in which we couldn't dream of doing before. So I'm going to go into more detail on that, but I want to show you an example that just illustrates some of what Noam can do. And it's an example called the Pongatron, and it's a game that we built using Noam, and the idea was to demonstrate the capabilities in a way that people could kind of just glance at and have a visceral reaction to. So the Pongatron is kind of a Rube Goldberg device in that this is the back of it, if you turned it around. It's using as many different technologies as we could, sort of unnecessarily complex environment, in order to illustrate how, even something that's like more extreme than a real world situation is easy to work within. So I have a video that I want to show you because that explains a little more. It talks a little bit about Noam, shows the Pongatron, and then we'll dive a little bit deeper afterwards. So you can switch the audio.
Noam is a platform that allows disparate prototyping technologies to work together to create single design experiences. Behind me, you're seeing a collection of a lot of different technologies. We've got a Mac Mini running processing, we've got Node.js running on a couple of Raspberry Pis, we've got, I think, 14 Arduinos controlling everything from LEDs to motors. And each technology expresses it differently. In the case of the iPads, you get this crisply rendered high-resolution ball, and on the RGB LEDs, it's this crude, almost 8-bit interpretation. And when you take that as a whole, it feels almost orchestral, with each technology playing its role as a different instrument, and together you get this vision of Pong.
Things are becoming more and more complex. We're not just doing a single iPad at the front of the store, or we're not just doing a physical product anymore. In order to have a true experience, you need to have all these things coming together. Noam enables us to take very, very different things that are already built and then start connecting them because they're what we need. So we needed an analog pixel. Oh great, we have this, let's bring it in. Oh, we have these LEDs, great, let's bring that in.
This is a great example of something that ordinarily might be quite challenging to do, to get all of those different technologies talking. But using Noam is quite simple, and only a couple of lines of code, in fact, to get each of those into a conversation where they're exchanging messages and creating what we call the Pongotron.
The system doesn't care what is what, it just, as long as it's listening and hearing the same messages. So we don't like this controller, all right, let's get rid of it. Let's bring in the iPad, right, or whatever it might be.
A great thing we're seeing with Noam is that because it makes technology simple, we're seeing the ability for a wide variety of different types of designers to participate directly in the prototyping process. We've been thrilled with a lot of the things that Noam has allowed us to do, and Noam was, of course, built using a bunch of great open source projects. We're thrilled to be able to release Noam as open source and see what the community does with it. We're hoping that people will take it, download it, and use it to create something and maybe share something back with us as well.
Okay, so how do you actually use Noam? So one of the things I want to point out is to install it, you download the disk image, you run the application installer, and you get a Mac app called Noam, right? There's no command line, there's no dependencies. It's just a Mac app. So it's one of the things that helps make this accessible to designers. When you launch the app, it pulls up the server, it asks you for a server name. This is the name of the conversation that you want to host between a bunch of different participants who are part of your prototype. And this is the name that those different pieces will use to connect to Noam. Once components begin to connect, there's an interface that shows them in this ring. So they're mapped visually on the Noam server. The guests are in this outer ring. You can see the conversations and messages that are being swapped back and forth. So it's nice just to see everything together. And the primary use of this particular interface is for debugging. You see how things are being passed back and forth and whether it's working. So lots of different technologies can join this conversation with Noam. They do it through a simple Noam library that's written specifically for each language. And these are what we call lemmas. And there's lemmas for all of these common technologies already. So it's pretty straightforward to just get up and use it. And then if you need to extend it to support a different technology, that's possible too, since it's open source. None of these technologies need to know anything about each other. So Noam is the middleman that takes care of all that. So I want to just show you a tangible example and use that vehicle simulator that was the genesis for Noam originally to make this a little bit more tangible. So let's say you're designing a vehicle prototype and you are designing the input and output for climate control. You need some kind of climate control in a car. So we start off with a pretty standard set of buttons on a pretty standard looking car dashboard along with our Noam server. So maybe we add a knob. There's a physical knob hooked up to an Arduino, and the Arduino joins the Noam conversation. So whenever the knob is turned, it can send a message to Noam using the speak command. So the idea is that the lemma speaks some variable. So in this case, it's speaking temperature. Whenever the knob turns, it sets the temperature to 68 or whatever it is based on the position of the knob. And it's really just this simple. It's one line of code, and then you have other Arduino-specific code to deal with the knob turning. But in terms of what Noam is adding to the code, it's very simple. But speaking isn't very interesting unless someone is listening, right? So let's add a screen that's hooked up to, maybe this is a screen running on a Mac or a PC that's a full screen web browser. So we can use the JavaScript lemma to listen or hear, it's speak and hear in Noam terminology, but it's hearing the variable temperature. So whenever Arduino speaks that the temperature has changed, Noam passes that along to JavaScript so that it can do something. It can update the display to show the current temperature. But the beauty of Noam is that it's not one-to-one. So for example, we could add another screen. Maybe it's a heads-up display that whenever you turn the temperature to something different, it flashes briefly in front of you, right? So in this example, we have another screen doing that, and it's running as a processing sketch. So totally different technology, but as you probably guessed, processing is also hearing temperature. So each of these lemmas is specific to the programming language. It's one of the really nice things. If you're familiar with processing, the code is going to be familiar. It's not making you learn anything new. If you're familiar with JavaScript, then you use JavaScript. Once these inputs and outputs are set up to hear when a certain variable changes from Noam, then we're free to change the input. So you notice the knob is gone, and we've replaced it with a series of preset temperature buttons. So each time one of these buttons is pressed, it's going to speak a different defined temperature, and those other screens are going to update accordingly. We could just as easily swap out that Arduino and those physical knobs for an iPhone app. And the iPhone app is part of the Noam conversation, so it can speak that the temperature has changed, through gestures or through buttons on the screen. The important thing to notice here is that processing and JavaScript have no idea that the interaction or technology has changed. They just know what Noam told them, that the temperature has changed. And so they react to that. So Noam basically makes it easy to swap inputs and outputs as you're trying out different ideas. It helps you keep ideas loose because you can always just try another one or go back to the previous one. And it lets you iterate fast and try things out during user testing and really up to the last minute. We've solved a bunch of the technical challenges and made it very designer-oriented so that you can just focus on iterating the design. Each one of these points I could go into in more detail, but I really just want to touch on a couple of them, and that is the idea that it's designed to be approachable and to work with all of these different tools and languages. So this is important because the modular nature of how you build something when you're using Noam allows everybody on the team to contribute. You don't have to standardize at the beginning of a project on one technology or another technology, and then only involve the people who know those. A quick example of that can be seen with the Pongotron, where a designer wrote a simple JavaScript app that does nothing but change the color of the ball. So this app doesn't know anything about the other components. It doesn't know that there's a game of Pong being played. The designer who wrote it doesn't know how to use most of the technologies involved. They've never worked with Arduino. They've never done any physical electronics work. They just took a language that they knew, like JavaScript, and made a program that spit out random hex colors, and everything else could respond to that. And so it's a great way to keep ideas loose when it isn't just you who can change them, when everyone on your team is equally empowered to tweak something and change it using the technologies that they're comfortable with. So, Noam is not some kind of cure-all. It's not necessarily something that you even want to use all the time. It's for solving a particular type of problem for a particular type of prototype. But the important thing I'm trying to communicate is that we need techniques to turn our intuition into strong ideas, and we need these processes and tools that help us hold them loosely. It doesn't just happen automatically.